everyone, myself Jayanti Balakrishnan from Group 6 presenting exclusively Chapter 7 The Renaissance. So these are the list of my members and everything was possible with the guidance of our lecturer. So moving forward, so when we talk about Renaissance, so what comes to your mind? Possibly the rebirth, or maybe an era where religion was no more their inspiration. But the most important thing when I say Renaissance, what should come to your mind is where they started to create works which mirrors themselves in real world. And perhaps Renaissance was the bridge connecting the Middle Age to the modern history. So let's move forward. How mathematics has helped during the Renaissance. So their contribution was first to the architecture. They did not use lines, they started to use circles for the structures that they have built, as what you can see here. You can see the circles here. Secondly is they have helped in music. How they have created and or modified this length of strings to give us new tones. As you can see here, this is the origin and they have modified their length to give us new tones. Thirdly, they have contributed in painting, where they started to create 3D shapes on flat surfaces. They used single point system to let things converge, and the third one was they used the technique of foreshortening to strengthen the effect of linear perspective. So as you can see is the 3D painting. This is the perfection of linear perspective where they start from a point and they converge the line, and this is a complete
Algebra in Renaissance. For early Renaissance, the first mathematician is Nicholas Chucker, who wrote a manuscript, Tripartite and Large Size Test Numbers in 1484, which was the earliest French algebra books. This is part of the manuscript, and beside algebra, he also invented spatial symbol and indices. He used the first letter of operations to describe operations such as P for plus and M for minus. And in his work of algebra, the negative number was used as the rule for solving the arithmetic problems. And here you can see the example of Chucker's symbol inventions. For Luca Pacioli, he wrote a lot of books, such as Summa de Arithmetica. On top of that, he published the first descriptions of double-entry bookkeeping. For late Renaissance, Cardano, he published first book on the rules of algebra, also known as Ars Magna, and in this book there's a method for solving cubic equations. Here is some of the notations used. The symbol represents the square root, and as for your information, Ars Magna is written in Latin. For the last part, discovering imaginary numbers. As for your information, Cardano was the first to use negative square root, and here is some of the problems involve imaginary numbers in the books.
Geometry in Renaissance. Renaissance buildings heavily relied on the use of geometry and the mathematics in their design, which heavily impacted other modern designs till now. Renaissance type of buildings relied on curves, arcs, triangles, circles, and squares, which are the main elements of geometry. As in the classical period, proportion was the most important factor of building, which Renaissance architects found a harmony between human proportions and buildings. This made Marcus Vitruvius superior to the human being as a model for the universe and use it in geometry and mathematics. Vitruvius believed that an architect should focus on three central themes when preparing a design for a building, which is strength, functionality, and beauty. He believed that the body's proportion could be used as a model of natural proportional perfection. He showed that the ideal human body fitted precisely into both a circle and a square. Thus, he illustrated the link that he believed existed between perfect geometric forms and the perfect body. Based on these ideas, Leonardo da Vinci made his own drawings based on the use of human proportions and the Vitruvius theorem. In the Renaissance age, it was their aim to put such ideas developed into practice in real buildings. Thus, he blended the use of circles and squares much in his general layout of his plan, and he divided it further into spaces through the use of columns, and as for the circular part, he used it to act as a dome, which was one of the most important figures in this period, which gives the building its texture and unique style. In this drawing, Leonardo made some adjustment to the Vitruvius measurement of the human figure, which was inspired by his own studies and observation, and he finally created the perfect image of a human figure with the best proportions. Based on Leonardo's plot, he drawn the Vitruvian man stretching his own legs and arms to form a perfect revolving circle around him and a square. However, in order to make this work, he had to place the circle centered, but the center on the square is a bit lower.
Trigonometry in Renaissance. Johannes Regmontanus first to see trigonometry as a mathematical discipline. Book he wrote, De Triangulis Omnibus and Tabulae Direction, systematized and advanced the plane and spherical trigonometry of the sine function. Used 6,000, 60,000 and 6 billion units for the radius of the arc, and separate trigonometry from astronomy. George Rheticus brought general systematization of Western trigonometry, introduced 7 trigonometrical functions, distinguished clearly between arc and angle subtended by it, published Opus Platinum De Triangulis in 1566, which contained explanation of trigonometric function in relation to right triangle rather than circle, tables of all 6 trigonometric functions to a 15-figure accuracy.
Hello everyone. So now we move to the development of logarithm. John Napier invented the logarithm in the early 17th century and later was improved by Henry Briggs. John Napier published the tables of logarithm in 1614 in his treatise named Description of the Marvelous Canon of Logarithms. The basic idea behind logarithm is that the addition and subtraction are easier to perform than multiplication and division. This invention of logarithm was contributed to the advance of science and mathematics by making some difficult calculations relatively easy. It was one of the most significant mathematical development of the age. The logarithm of a number is the exponent when the number is expressed as a power of 10, or it could be any other basis. It is effectively the inverse of exponentiation. For example, the base 10 logarithm of 100 is 2, and usually it written as log 10 100 or just log 100 because 10 power of 2 is equal to 100. The value of logarithm arises from the fact of multiplication of 2 or more numbers is equivalent to adding their logarithms, a much simpler operation. Division also involves in the subtraction of logarithms. Squaring is as simple as multiplying the logarithm by 2. Square roots requires dividing the logarithm by 2 or by 3 for cube roots. Although base 10 is the most popular base, another common base for logarithm is the number e, which has a value of 2.7182818 ... It has special properties which make it very useful for logarithmic calculations. These are known as natural logarithms and are written as log e or called as a ln.